Hi, and welcome back to my Physics Online video series. Today's video is a lab walkthrough video for the Physics 2 courses Ampere's Law Lab. So as always, if you are taking one of my courses, you have a set of lab instructions which you should have read through before coming to watch this video. This video is not to do the lab for you, it's instead only to do the basics of getting your setup so you can see what to do, and the basics of the calculations that you're supposed to do, all within about 15 minutes. So again, you should have read all these instructions before coming here so that you know what it is that we're doing instead of my having to read them to you. If you've clicked on the link in your instructions, then you have headed to this web page. You can hit begin, and then there is a magnetic field detector. You want it in the two-dimensional, and the grid is sort of easiest to deal with. You have a field strength measurement, and then down at the bottom, kind of off screen in this video recorder, unfortunately, we have location of field sensor, direction of electron flow, and then below the video there's also current. So first thing you're supposed to do is get the location set up correctly. It's currently at the location 5 and 5, so we're 5 along X, 1, 2, 3, 4, 5. We're up 5 centimeters along Y, and it says to adjust it to 5, 4, so that would be right here. We're again 5 along X, 4 along Y. You're also supposed to set all the other default values. So we should have everything set up basically as shown here, with the current somewhere between 4 and 5 amps. Now what you're doing is basically measuring the field strength as a function of the position along X and Y of the sensor, which is moving this way and this way for X, and this way for Y. Only change either X or Y, but not both when you're measuring. And then current obviously is changing these two arrows. So you're going to be making changes for all three of those things, and in each case you're measuring what the magnetic field strength is. So you can move up and down, you can move left and right, and then you can increase or decrease the current. And in each case you should be writing down the magnetic field strength as well as the value of the changed variable, your independent variable. Specifically, if you're going in order of the directions, you start by looking at the you start by setting up the control parameters as I did, and then first you change horizontal positions, so you're basically moving the sensor left and right. Then you reset it to your sort of control position at 5, 4 centimeters. Then investigate the effect of current, so you're changing just the current. Then return that to between 4 and 5, and then you adjust the vertical position, so move it up and down. For each one of these three things, you're making a plot. Some plots may just be a horizontal line, in which case you can sort of say, like, this does not affect the magnetic field, or magnetic field doesn't depend upon this. In other cases, you'll get something else, some other function, straight line, an inverse, inverse square, exponential, parabolic, something. And so if you get a straight line, great, then you hand in your straight line graph and it's a linear relationship. If it is not a straight line graph, then you need to linearize it. to figure out what the functional relationship is there. Now, we've done this a few times before, so I'm not really going to go into the details of how to linearize a graph or what that means, but functional relationship-wise, if I went through and I made a plot of magnetic field strength, which we use a B for, versus some variable, let's say we're using x squared as our variable, and the result is a straight line, then B is equal to some constant. I'll use like a K for constant. I know the constant starts with a C, but we use a K for constant times x squared. That's essentially like the rationale here. Now, you may also have another one where you have some other variable y that you have plotted and gotten another straight line. So maybe we call this one the x constant. This one right here, b k, the y constant, times y. And this x constant should contain essentially some constant times essentially y. Let's actually just say some constant parenthetically times y. This one right here would be the same constant, as this, times x squared. And maybe we should call this y naught and x naught, or x naught squared. So this y naught would be 4 centimeters. This x naught squared, 5 centimeters squared. May need to convert those units. So need to convert units. And that's that. So then you're turning in those plots, and so if we look back at the instructions, it kind of goes one further and says, using your graphs, determine the value of the constant mu naught. You're going to have two graphs, both of which give mu naught. Get the value from each of those two graphs and compare them, and compare it to the expected value of 4 pi times 10 to the negative 7. So this some constant, it's not that this constant is mu naught, it's that we expect it to be maybe like 4 pi times mu naught. Or it may be that we expect it to be mu naught over 2 or mu naught over 2 pi, something like that. But essentially your constant is a multiple, so is a multiple of permeability of free space mu naught. So that is what this constant is expected to be. And that's it for the lab. That's all you're doing. How do you get mu naught? Well, how did you get these k's? Well, this is a slope, and this k is the slope of this. After, of course, some appropriate unit changes. So that's it. It is really a fairly straightforward lab if you do all these things. And hope you enjoy it. Hope you all get some good results. Please note that you're getting experimental results, so you're not going to get exactly 4 pi times 10 to the negative 7 as your answer. Like maybe you get 4 times pi minus 0.01 all times 10 to the negative 7, or 4 times the quantity pi minus 0.07 all times 10 to the negative 7. you're not going to get an exact answer because this is experimental, and this particular simulation attempts to simulate some amount of error as well. So you will get some values that should be close, and then you should make your comparisons. And that's it. Hopefully you found this brief walkthrough helpful, and see you in the next one.